In this video, I'm going to show you how to find the roots of a rational function with common factors in the numerator and denominator. So here we want to find the roots of f of x, which is equal to x squared minus 7x plus 12 over x minus 3, where x is a real number. And how we find the roots are, we just set f of x equals 0. So 0 equals f of x. The solutions to that equation are the roots of the function. Okay, so let's go ahead and write this in. So 0 is equal to that expression for f of x. 0 equals x squared minus 7x plus 12 over x minus 3. Now, one thing to notice immediately here is that x cannot be equal to 3. Let's write that down here. X is not equal to 3. And the reason that is because if x were equal to 3, then the denominator would be 0, and then this right-hand side of the equation would be undefined. We call this value of 3 an excluded value. And we call it that because this value 3 should be excluded from whatever solutions we come up with this equation. If we come up with a solution of 3 as we're manipulating, then we should remove that from our solutions at the end. Okay, so with that in mind, let's go ahead and solve this equation. Let's go ahead and first let's factor the numerator. So 0 equals, what is this factor to? Well, that is just x minus 3 times x minus 4, and that's over x minus 3. And now we can cancel these common factors. X minus 3 cancels with x minus 3, and we're left with just 0 equals x minus 4. To solve that, just add 4 to both sides and get x is equal to 4. So our solution is just the set 4. And the solution 4 is different from our excluded solution of 3, so we're all good. This is truly the solution. Before we go on, let's elaborate a bit more on this excluded value. We already talked about how having 3 for x makes the denominator 0, which makes the right-hand side here undefined. But this excluded value has a graphical interpretation as well. So why don't we draw a set of axes here, and we'll just do a rough sketch of f. Alright, so we know that f can be simplified to x minus 4, provided that x is not equal to 3. So that means that f looks like the line f equals x minus 4. Why don't we draw, let's draw that. Looks something like this. But at the value x equals 3, there is a hole in the graph. So f of x looks like this, but at this x value of 3, there is a hole in the graph. So that's why we would need to remove the value of 3 from any solutions we get, because 3 is just not even in the domain of f. Here's another example. This time it's a bit tougher. We've got a cubic over a quartic. Okay, so let's go ahead and try to find the roots. So remember, to find the roots, we're just solving set f of x equal to 0. 0 equals f of x, and we'll plug in our expression here for f. So 0 is equal to 2x to the third minus 4x squared plus 3x minus 6, all over the quartic 2x to the fourth minus 5x squared minus 12. Now, why don't we do some factoring work here? We'll do this off to the side, so create a little section for our factoring work. And first of all, we'll factor the numerator, so 2x to the third minus 4x squared plus 3x minus 6. And we can do this by grouping, so let's go ahead and group up those highest degree terms and those lowest degree terms. Let's pull out a common factor, so pull out 2x squared from the first group, and we have just x and then minus 2, and then pull out a 3 from the second group, so plus 3 times the remaining terms are x minus 2, and then we can pull out an x minus 2 from both of these terms. We've just got our 2x squared and then plus 3. So numerator can be factored to this. Let's go ahead and write that down. So 0 is equal to 2x squared plus 3 times x minus 2, and that is all over, well, let's go ahead and factor the denominator. Denominator will also do on the side here, so that's 2x to the fourth minus 5x squared minus 12. And that's a bit easier to factor because it's really similar to a quadratic, except here we're working with x to the fourth and x squared. So this is just going to be 2x squared plus 3 times x squared minus 4. And now notice that we can factor this even further. So 2x squared plus 3, and then x squared minus 4, that's a perfect difference of squares. So x plus 2, x minus 2. So let's go ahead and write that in for the denominator. That's 2x squared plus 3 times x plus 2 times x minus 2. Okay, so before we move on with canceling, let's take a look at our excluded values here. So excluded values are just going to be what makes the denominator 0. So immediately we can see that if x plus 2 is 0, that's going to cause a problem because denominator is undefined. So we can't have, we need to have x is not equal to negative 2. That makes this factor 0. Likewise, if we have x equal to positive 2, then that makes this factor equal to 0. So x cannot be equal to negative 2 or positive 2. And also, this factor right here, 2x squared plus 3, we can't have that equal to 0. That's going to require a little bit more algebra work to see what values of x make that 0. So 2x squared plus 3 equals to 0. What causes that? Well, if we solve for x here, we've got 2x squared equals negative 3, then x squared negative 3 halves, and so x is just equal to plus or minus root of negative 3 halves, but that's going to be an imaginary number, and we're just considering real numbers of x, so this really doesn't matter. We can just forget about that. The excluded solutions are then just x is not equal to negative 2 and not equal to positive 2. Okay, great. So now we've got our excluded solutions, and we can go ahead and cancel terms here. So 2x squared plus 3 cancels on top and bottom, and x minus 2 cancels on top and bottom, and what we're left is just 0 equals 1 over x plus 2. But the numerator of this fraction is never equal to 0. It's just a constant 1, so no matter what we plug in for x, we'll never get that numerator equal to 0. So this equation just has no solution. And as a result, f of x has no roots. In this video, we focused on finding the roots of rational functions. But in the future, we'll also extend these ideas to learn how to find solutions to rational equations.